All right, so ladies and gentlemen, we got chapter 3.5, quadratic inequalities. We have done inequalities in the past, and that's why I have this warm-up. Brr, it's cold outside, like 40 degrees out and windy. We're not going to do both of these. We're going to just do one of them. Okay, these are linear inequalities. Okay, so just a refresher on linear ones. Okay, I'm going to do number 2. This is an and. So this is an and inequality. So I always said, hey, think of this as 3 different columns, 1, 2, 3, and whatever you do in one column, you got to do in the other. So if we subtract the 2 over, got to do it over there also. So you got to do it in all 3 columns. So we get 2 is less than or equal to 2x, which is less than or equal to 8. And then the last step, divide everything by 2, divide by 2, divide by 2, and we get 1 is less than or equal to x, which is less than or equal to 4. Okay, so that's an and remember ands, low number, high number, and then we shade in the middle, and then if it's equal to, we do brackets. So it'd have a bracket on 1 to 4 bracket. Okay, and that's my interval notation for a and inequality. Okay, I'm going to skip over 1. I don't think we need to go through that today. Just want to get to the good stuff. Goal number 1, here we go, solving inequalities involving a quadratic function. Now, I think it's very important that you guys understand visually what's going on. So that's what I have example 1 and 2 for us. Okay, so when I take a look at example 1, it says, where is f of x less than 0? Okay, well, f of x is this function, x squared minus 4x minus 12. We probably know that's a quadratic or parabola. Okay, and we want to know where this graph is less than 0. Okay, well, if you don't remember, y equals 0 is just the x-axis. Okay, so then I propose the question to you guys visually, where is the blue one less than the red one? So where would you guys explain that to your buddy? Like, hey, this is where the blue one is less than 0. Where is the blue one less than the red one? How would you guys explain that? What would you guys say?
Anywhere below the x-axis.
Yeah, so anywhere below this red line. Okay, so as I'm looking, and something you should make note of, if I have less than or equal to, visually I'm looking below. I'm looking to see where is it below the x-axis, where is this thing less than, where it's negative, less than 0. So as I follow this graph, I'm going to kind of do squiggles on where I think it's below. So this is above, above, on, and then below, 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 on, and then above. So everywhere in between -2 and 6 is where it's below. Okay, and if I was looking at a number line, here's -2, here's 6, my shading would be all right there. Okay, and it's not equal to up here, it's just less than 0, so it's going to be parentheses. Okay, so my final answer would be -2 to 6, like that. Remember, that's interval notation. Okay, so final answer, -2 to 6. That's not so bad. Okay, so when we look at the next one, I've got f of x is greater than or equal to g of x. Okay, so now they're comparing 2 functions. Okay, they kind of did that already. 0 is a function. It's the constant function. Well, this case, f of x is this quadratic. F of x equals 2x squared. Okay, this guy right there. And then g of x is this line, x plus 10. Okay, well, in this one, they're asking us where it's greater than or equal to. Okay, well, greater than or equal to, or greater than, is just the opposite of below, and the opposite of below is above. Easy peasy lemon squeezy. So look at the quadratic. Where is the blue one above the red one? Above, 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 on, below, 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 on, above, above, above. Okay, so all the squiggles there. So if I was looking at a number line, it intersects here at -2, and 5/2 is where that coordinate point is for x. Remember, it's always x's on where stuff is happening. And then the shading would be on the outside, like an or. Okay, it's equal to, so I'm going to have the brackets. Okay, so where is it greater than or equal to? So interval notation, remember we start on the left where it's negative infinity. Here's to the right, infinity. So you read it left to right. So I would have negative infinity to -2 bracket. Union or, my math lab's going to probably want the U, this guy right here. And that'll be an option for you when you're doing interval notation. And then I have 5/2 to infinity. And that's it. That's what we're looking for interval notation. Okay. Questions, y'all? That's not so bad. So again, make sure you have this on your notes. And remember, you can use your notes for your test. Less than or equal to is below. Greater than or equal to is above. Okay. Well, if you can do it visually, then the next step is to do it algebraically. Do you guys have any questions with 1 or 2, y'all? Speak now or forever hold your peace. Any questions, y'all? Give me a thumb. Give me a thumb. Thumb, thumb, thumbs are up. All righty. All right. So let's take that into action. Guys, this is the last page of notes. It's a beautiful thing when you get to the last page of notes for the whole chapter. So when I take a look, it says goal number 1, we're going to solve these things algebraically. Step 1 is to get your function less than or greater than 0. So greater than 0, less than 0. So basically we want to get our stuff on one side and then greater than 0 or less than 0. So for example 3, well, the first thing we need to do is subtract over. Subtract that 12. And now we have x squared plus x minus 12 is greater than 0. Right in descending order so we can do the next step, which is to find the zeros. Zeros, or x-intercepts, okay, is where it touches or crosses the x-axis. And to do that algebraically, all we do is factor. So teach me how to factor. Teach me how to factor. Everybody factor. Everybody factor. Show you what when you factor. So we need to factor this guy. I'll do the first part. Factors of the first term is x and x. What are factors of -12 that add up to 1x? What do you guys got for that? Factors of -12. 4 and -3. So x plus 4, x minus 3. Fantastic. Now, if you need to, you can set each one of those equal to 0 and solve, but we know the little trick for zeros. Just set x plus 4 equal to 0, and you would subtract over it. It's the opposite sign. So if you see x plus 4, the 0 is -4 because -4 plus 4 is 0. And if you have x minus 3, you would add the 3 over and you get a 0 of 3. So I do zeros. I call it z's. My z's for short. That's a z for me. My 0 is -4 and 3. Now put that on a number line. So step 3, use the numbers in step 2 to create intervals. So we're going to put that on a number line. And basically what we did was we created 3 different sections or intervals that we need to test. Okay. So step 4 is now they want us to test for pluses and minuses. Okay. So what does that mean? Well, we want to choose a number in these intervals and test them and see what we get. Okay. Why do we want to do that? Well, we have numbers that are going to be greater than 0 or greater than equal to 0. Well, those numbers, mathematically, numbers that are greater than or greater than equal to 0 are positive numbers, right? And numbers that are less than 0 or less than or equal to 0 are going to be negative numbers. Okay, if I have a number less than 0, that's going to be -1 or -2 or -3 or whatever. All right, well, I usually start in the middle because the easiest number to plug in is always 0. So I can plug in 0. 0 is in between -4 and 3, right? So plug in 0 here and here for x. I can use the cover-up method. I would get 4, and I would get -3, and I multiply 4 times -3 is a -12. Or I can use the cover-up method here in the red one. I would get -12. Okay. So this whole region, no matter if I chose 0, 1, 2, -1, -2, -3, anything between -4 and 3 is going to give me a negative number. Okay. Now I can choose a number over here. Give me a number to the right of 3. What's a number to the right of 3? Over here.
4.
Okay, plug in 4. 4 plus 4 is 8. 4 minus 3 is 1, and I would get 8 times 1 is a positive 8. That's a positive region. So if I pick any number over there, it's going to give me a positive. And then I can do the exact same thing over here, like -5 or -6 to the left of -4. Plug that in. If I plug in -5 plus 4 is -1. -5 minus 3 is -8. I get -1 times -8. Negative times a negative is a positive 8. Okay. Now visually, what's going on here? Well, this is just a quadratic that crosses the x-axis at -4 and 0, right? Where it's negative is where it's below the x-axis. Where it's positive is where it's above the x-axis, okay? And we're looking for the pluses. We're looking for above. We want to know, where is it greater than 0? So that's where my shading is. My shading is on the outside, okay? It's not equal to, so I'm using parentheses then. So my final answer for interval notation, does this make sense now? We're looking at a parabola here, right? My answer, where's this thing above, is from -infinity to -4, parenthesis, union or, I would use use for my math lab, 3 to infinity. And that's it. That one's done. All right, any questions with that one, y'all? All right. So I'm going to skip over 4 for notes, try to work on ones that I think we need to work on. Let's work on the next one. So I got example 5. Step number 1, get your stuff on one side, so I need to subtract the 2 over. Okay, write in descending order. So I got 2k squared plus 3k minus 2 is less than or equal to 0. Then we got to factor this guy. I'll do the first part. Factors of 2k squared are 2k and k. Now we got to come up with factors of -2. That when you do your outsides and inners, your nose and smile of SpongeBob, I call it the OI check. That's going to give you a 3k. So this is your OI term. This is your F. This is your L. So I do factors of F and L that add up to OI. So how are we going to break down -2? Is it going to be -2 and 1? Or is it going to be -1 and 2? +1 and 2? I don't know. How are we going to break this down? Plus, minus, minus, plus. 1, 2, 2, 1. What are we going to do?
-1 plus 2.
-1 plus 2, Kaylee says. -1 plus 2. I don't know. Let's check. Outers, 2k times 2 is 4k. -1 times k is -k. Add it up. Yes. Check. That's what we wanted. Okay, we want that middle term to be 3k. So now I know I set it up right. Zeros is what makes those quantities zero. So I know this one, k plus 2, is opposite, -2. And then if you need to, set 2k minus 1 equal to 0. If you need to. But a lot of you guys can just do this in your head. You would add 1 and divide by 2. You get 1/2. Okay, low numbers on the left. Low left. Big numbers on the right. So 1/2 is bigger. So it's there. Okay, now 99% of the time it's going to follow the same pattern. This is a smiley face, right? So I got a nice, pretty smiley face here. Smiley, smiley, smiley face. When I graph this thing, it's going to look like this. This is the negative region. This is where it's below. This is where it's above. Okay. So it's 99% of the time, it's going to be plus, minus, plus for quadratics. Okay. I'll show you some instances where it's not, but very rarely does that happen. Okay, so I got plus, minus, plus. What am I looking for? What type of numbers? What's this? What type of numbers are less than or equal to 0? This is how I decide on the shading. Do I shade in the middle? Do I shade on the outsides?
Negative.
Yeah, I'm looking for the negative region, right? Numbers that are less than or equal to 0 are the negative numbers. Very good. It's equal to, so I'm going to have the bracket as well. Okay. So from left to right, the part that's shaded, I have a bracket on -2 to 1/2 bracket. All right. Any questions with that one? All right, turn your mics on. How do we do the next one? Let's get some new people out here helping out. How do you do it? Last one we got to do. Subtract the 2x to both sides. All right, all right. So I've got x squared minus 2x minus 15. Make sure you're writing in descending order. And that's greater than or equal to 0. Okay. Factor this one for me. What are factors of -15 that add up to -2?
-5 and +3.
-5 and +3. Is that what I heard? Multiply together is -15. Added together is -2. So fantastic. Zeros. Set each quantity equal to 0 and solve. You get 5 and -3. That's what we put on the number line. And then we do our testing. Okay, smiley face or frowny face? What type of quadratic are you guys getting? What is this graph going to look like? How do you know?
Smiley face.
Smiley face because this guy is positive.
Yeah.
So I would make a smiley face here. And now this is the minus region. That's where it's below the x-axis. And this is the side that it's above. Okay. And then what are we looking for? We want numbers that are greater than or equal to 0. This is how I decide on the shading. Numbers that are greater than or equal to 0. That's where it's above. So I hope you have this written somewhere. Greater than 0, greater than or equal to 0 is pluses. That's above. Less than or equal to 0 is the minuses. That's where it's below. So this is greater than or greater than or equal to 0. That's here and here. That's here and here. It's equal to, so it's a bracket. So left to right, -infinity, -3. Stop. Don't see it, don't see it, don't see it. Picks back up at 5. And it goes all the way to infinity. Okay. If you write this in my math lab, it's going to be wrong because they want the U in between. Okay. Union is for or, this one or that one. Put them together. Okay. All right, some instances that you might run into. I want to show you different two scenarios here. You might actually get the exact same thing, but you get -x squared plus 2x plus 15 is less than or equal to 0. Okay, so you might run into one that's a frowny face. Well, you can always turn that frown upside down by just dividing everything by a negative. And when you divide everything by a negative, it just flips every sign. So x squared, -2x, -15. And when you divide both sides by a negative, you must flip that sign as well. That is now greater than or equal to. And then you would get this one and that one to be the same. Okay. Now you could factor this. It's just, I don't like factoring number one when there's a negative in front. So that would be the first thing I do. Just don't forget to change the inequality sign. Okay, so that's one other scenario. Another scenario you might see is if you had like x minus 6 quantity squared is greater than 0. Okay, the 0 of that function is only 6. Okay, so here's 6. And if I do some testing, a number to the left of 6 would be like 0. Well, -6 squared is positive 36. That's a positive. And a number over here would be like 7. 7 minus 6 is 1. 1 squared is positive. Well, this thing is positive everywhere. Okay, and that reason is this is a quadratic that touches the x-axis and goes back up. So the graphing would be everywhere except for 6. And to say that using interval notation would be negative infinity to 6, union or 6 to infinity. We just have parentheses on the 6. Okay? Now, if they ask that same question, where is x minus 6 squared less than 0? Where is this graph below the x-axis? Well, the answer is no, nowhere. The answer is no solution. You can't find it below the x-axis. Okay? So that's what I got for you guys. That's chapter 3.5. Do you guys have any questions for me?